When I first heard the phrase, if you stare long enough into the darkness, it might stare back, I didn't realize how perfectly it described black holes. Back then they seemed like distant cosmic traps, silent and unreachable. But the deeper I went into studying them, the more I understood. A black hole is not emptiness. It's a boundary between the familiar universe and something profoundly different. Imagine standing in the quiet of space, where every sound is swallowed by the void. In front of you, a massive, invisible whirlpool. You don't see it directly. You only see the light it bends, the stars it distorts, the way the background behind it stretches like melted glass. That's how I picture a black hole, not as a monster, but as a place where reality curves into something beautiful and strange. At the heart of every black hole lies the singularity, a point so dense and so extreme that our laws of physics simply stop working. Time, space, matter, everything collapses into a mystery. The singularity is like the final page of a book that hasn't been written yet. We know it's there, but we don't know what it says. Surrounding it is the event horizon, a boundary I always imagine as a cosmic shoreline. The last place where light can still escape, the last safe step before crossing into the unknown. If someone fell toward it, we would watch their movements slow down, as though time itself stretched to a halt. They would fade, freeze, and eventually disappear, not because they stop moving, but because the universe bends their story into silence. Yet there is something strangely peaceful about it. The idea that the universe has a place where time behaves differently. A place where the rules don't simply break, they transform. What fascinates me even more is what happens around the black hole. Matter spiraling inward heats up, glows, and forms an accretion disk, a bright, swirling ring of energy. If you looked at it from afar, it would resemble a cosmic halo shining around an invisible center. It's poetic. The thing known for swallowing everything is surrounded by a crown of light. But even this beauty hides danger. The gravity near a black hole stretches objects like strands of spaghetti, a real scientific process called spaghettification. A star wandering too close can be torn apart, its pieces swirling into the black hole like glowing threads. And although it sounds violent, it becomes one of the most incredible sights telescopes can capture. The last light of a doomed star, shining in one final arc across the void. To me, this contrast, darkness at the center, light spiraling around it, is why black holes feel almost alive. They aren't dead zones. They're the universe reshaping itself in silence. And the most surprising part? Everything we know about black holes is still just the beginning. The moment I realized how alive the universe truly is happened when I first listened to gravitational waves, tiny ripples in space-time created by massive cosmic events. It's strange to think about it. Space itself can vibrate, stretch, and carry a memory of something that happened billions of years ago. When the first detection came in, it sounded like a short, rising chirp. Simple, quiet, almost humble. And yet that tiny sound was the echo of two enormous black holes colliding in a place far beyond our imagination. To me, that discovery felt like hearing the universe whisper for the very first time. I often imagine what that collision looked like. Two invisible giants spiraling closer and closer, moving faster than anything we could ever see on Earth. Their dance warps the fabric of reality, bending time, twisting space, sending waves outward like ripples across an endless ocean. And then, in an instant, they merge into one. A new black hole is born, heavier, stronger, stranger. But even this dramatic event isn't the most mind-stretching concept about black holes. There's a theory that has fascinated me for years: white holes. If black holes pull everything inward, then white holes would do the opposite, push everything outward, never letting anything in. They're like cosmic fountains, hypothetically throwing out matter and energy with impossible force. No one has ever seen one, but the idea alone changes the way we think about the universe. And some scientists believe black holes and white holes might be connected, forming something like a tunnel, a theoretical bridge through space-time. A wormhole. The idea sounds like science fiction, but mathematically it's not impossible. Imagine two distant parts of the universe connected by a hidden passageway, a tunnel formed by extreme gravity. You enter through a black hole, you exit through a white hole. The journey might take seconds, even if the distance is millions of light years. Of course, we don't know if anything could actually survive such a trip, but the possibility itself sparks curiosity. It raises a deeper question. What if black holes aren't just destroyers, but gateways? Some physicists even propose that inside each black hole, beyond the event horizon, a new universe might exist, a universe with its own stars, its own laws of physics, its own version of time. In that view, our entire universe could be the inside of a black hole formed in some larger, older cosmos. It's a wild thought, but not an impossible one. And the more I think about it, the more I realize how little we truly know. Every discovery only opens another layer of mystery. Every answer leads to 10 new questions. That's the beauty of it. Black holes aren't frightening because they're dark. They're fascinating because they're full of unknowns. When you consider how vast and ancient they are, how they bend reality itself, it becomes clear that black holes might be the key to understanding everything from the origins of time to the future of our universe. And just when you think the mystery is solved, the universe surprises you again. There is a question that has followed me ever since I first learned about black holes. What actually happens to information that falls inside? In our everyday world, if you burn a piece of paper, it transforms into ash and smoke, but the information it carried, the arrangement of its atoms, isn't gone. It's simply changed. Physics insists that information can't vanish completely. But a black hole challenges that rule in the most dramatic way possible. If something crosses the event horizon, we can't observe it anymore. It disappears from the outside universe forever. So the puzzle arises, does the information disappear too? Or is it somehow stored, encoded, hidden in ways we can't yet understand? This is known as the information paradox, and it has sparked debates among the greatest minds in science. Even Stephen Hawking himself spent decades exploring it. One idea suggests that the information becomes painted on the surface of the event horizon like a cosmic hologram. Another proposes that it escapes through a faint radiation, what we now call Hawking radiation, slowly leaking back into the universe over unimaginable timescales. To me, this paradox makes black holes feel like libraries with locked doors. They collect stories, the stories of stars, planets, and particles, but they don't let us read them. And this leads to something even more mysterious. Black holes aren't truly black. As they absorb matter, they also emit energy. Not from within, but from quantum effects happening right on the edge of the event horizon. This radiation is incredibly faint, weaker than a whisper in an empty field, but it means that black holes can slowly evaporate. Yes, they can disappear. Not today, not tomorrow, but over trillions of years. Imagine that something powerful enough to swallow stars can eventually fade away like a dying ember. But what happens at the very end? When a black hole finally evaporates completely, does it reveal the information trapped inside? Or does it vanish forever? We still don't know, and that not knowing is what makes the mystery so compelling. The universe hides its secrets well. And the strangest of those secrets might be the way black holes affect the fabric of reality itself. Their gravity can twist light into perfect rings called Einstein rings. Their presence can stretch time so intensely that a minute near a black hole could be hours, days, or even years for someone far away. Every time I think about this, I imagine standing near one, not close enough to fall in, but just near the edge. The stars around it would ripple and distort like reflections on a lake after a stone is thrown. The passing of time would feel different, almost softer. You would be witnessing the universe bending like warm metal. And the most surreal thought? Black holes might be the engines that shape galaxies. The giant black holes at their centers act like gravitational anchors, keeping billions of stars in orbit. Without them, galaxies might not exist in the forms we see today. So, instead of being destroyers, black holes may actually be creators on a cosmic scale. Silent architects working in the dark. And just when you think you understand their role, you realize the mystery goes even deeper. The story isn't over, it's only gaining momentum. The closer we get to understanding black holes, the more they begin to feel like messages written by the universe itself, messages we are only just learning to read. And the final mystery, the one that lingers behind every scientific paper and every observation, is this. Are black holes the end of everything or the beginning of something entirely new? Some theories suggest that when matter crosses the event horizon, it doesn't simply vanish. Instead, it might transform, compress, and take on a new role in shaping the universe. What we perceive as destruction could actually be the first step of creation. In this view, a black hole is like a seed, dense, invisible, and holding the potential for something unimaginable. There's a breathtaking idea proposed by several cosmologists. Each black hole might give birth to a new universe. Imagine that inside the singularity, instead of a point of infinite density, there exists a bridge to a vast expanding space, a sort of cosmic branching. In this scenario, our own universe could be just one of countless others, connected through the hidden hearts of black holes scattered across a larger reality. It sounds unbelievable, almost mythic, yet the mathematics behind it isn't impossible. And that is what makes the universe so astonishing. Truth often turns out to be stranger than any fiction we can invent. But there is one more twist, perhaps the most mind-bending of all. Quantum physics suggests that reality is not as solid as it seems. Space and time might be woven from tiny informational threads. If that is true, then black holes could be the ultimate knots in that cosmic fabric. They store information, reshape it, stretch it, compress it, and maybe even pass it onward into new realms. In a sense, black holes could be the memory keepers of the universe, preserving the past while influencing the future. And then comes the most human question of all. What would it mean for us if black holes truly connect worlds, preserve information, and shape galaxies? It would mean that the universe is far more alive, far more intelligent, and far more interconnected than we ever imagined. Whenever I picture a black hole now, I no longer see it as a void. I see a doorway, a silent, powerful boundary, beyond which lies a story we haven't read yet. A story that might reshape everything we know about existence. And here is the reason this mystery is so captivating. Every time scientists make a discovery, it only deepens the intrigue. Black holes don't give final answers. They invite us to keep looking, to keep questioning, to keep imagining. They remind us that curiosity is the real engine of discovery. So if you ever find yourself staring at an image of a black hole, that glowing ring of light around a dark center, remember this. You're not looking at emptiness. You're looking at possibility. You're looking at the edge of the known universe and the threshold of everything beyond it. And the best part, this story doesn't end here. The universe has many more secrets to reveal, and we're just getting started. Stay with me. The journey only gets more interesting from here.